Good morning, students. In this video, we are going to learn about the redox reactions. Redox reactions are the foundation of many chemical processes that occur in our daily life. For example, rusting of iron. For example, tarnishing of silver. Another example is respiration. Respiration is also an example of a redox reaction. Another example is photosynthesis. So, redox reactions are the foundation of many chemical processes that occur in our daily life. Before start, I will ask some questions. The first question is, why does iron rust? The second question is, why does burning is considered as a chemical reaction or chemical change? The answer, you will answer the questions in the comment box. Okay. So let's start the redox reaction. Redox, the word redox. If we break down the word into two parts, one is red, another is ox. Red means reduction, ox means oxidation. So the reaction in which both oxidation reaction and reduction reaction occur simultaneously, takes place simultaneously. Those reactions are known as redox reactions. Let's study oxidation and reduction one by one. The first one is oxidation. If if a chemical A gains oxygen and losses hydrogen, then it is called as oxidation of A. We can say A is oxidized. Okay, when any element, this is the classical definition. When any element gains oxygen, or we can say addition of oxygen and removal of hydrogen is known as oxidation, and the substance is said to be oxidized. Okay, then reduction. If a chemical B gains hydrogen and losses oxygen, it is called reduction of B, and B is said to be reduced. In other words, the addition of hydrogen and removal of oxygen is known as reduction, and the substance is said to be reduced. Let's take a simple example. Zinc oxide plus carbon is raised to Zn plus zinc plus CO, carbon monoxide. This is an example of redox reaction, because in this reaction oxidation and reduction takes place simultaneously. See here, ZNO, zinc oxide, losses oxygen to form zinc. The loss of oxygen is known as reduction. That's why zinc oxide is reduced to zinc. Then the carbon gains oxygen to form carbon monoxide. The gain of oxygen is known as oxidation. So carbon is oxidized to form carbon monoxide. So here the oxidation of zinc oxide takes place and the reduction of carbon takes place. So this is a redox reaction, because both oxidation and reduction occur. Another two important terms are oxidizing agent and reducing agent. The which is element which is reduced is known as oxidizing agent. Here ZnO, zinc oxide, is reduced to zinc. That's why zinc oxide ZnO is an oxidizing agent. Very simple. The substance which is reduced, whose reduction occurs, that is known as oxidizing agent. And the element which is oxidized, whose oxidation takes place, is known as reducing agent. Here, carbon is oxidized to form carbon monoxide. Oxidation of carbon takes place. So, carbon is the reducing agent. Understood? Oxidizing agent and reducing agent. Let's take another example. Very simple example. Manganese dioxide MnO2 plus 4HCl hydrochloric acid gives rise to MnCl2 manganese chloride plus 2H2O water plus Cl2 chlorine. Here MnO2 manganese oxide is reduced because it loses oxygen to form MnCl2 magnesium manganese chloride. Here loss of oxygen from MnO2 takes place. So manganese oxide MnO2 is reduced to form MnCl2. Reduction occurs. So MnO2 manganese dioxide is an oxidizing agent here, and here HCl hydrogen chloride is reduced to Cl2 because in HCl there is hydrogen, in Cl2 hydrogen is not there. So loss of hydrogen occurs. So loss of hydrogen means oxidation. So HCl is oxidized, oxidation of HCl takes place. That's why HCl is known as the reducing agent here. Okay, understood? Let's take another example. That is oxidation of copper. Cu copper plus O2 oxygen gives rise to CuO, copper oxide. Copper is reddish brownish color. The copper oxide is black color. So here addition of oxygen occurs. Oxygen is added to copper. So it is an oxidation reaction. Cu gives rise to CuO. Okay. This is an example of oxidation reaction. We can give another example. CuO plus H2. If we add hydrogen with copper oxide, then what happens? Then it will form Cu plus H2O. In this reaction, from copper oxide to copper, here loss of oxygen takes place. So this is reduction. This is an example of reduction reaction. And CuO, copper oxide, will act as which agent? Oxidizing agent or reducing agent? Since reduction takes place, so it is an oxidizing agent. CuO is an oxidizing agent. Okay. The oxidation of copper is a very important example. Frequently asked in examination. If we take a China dish in the laboratory, we take China dish. In the China dish, we take copper powder. Then we heat the China dish in Bunsen burner. Then what happens? After some time, the color of copper is changed from reddish brown to black color, and the black color substance is copper oxide. Remember, and the if hydrogen gas is passed over the copper oxide, black color copper oxide, the black color again changes to brown because reduction occurs. So this is also an example of redox reaction. This was the classical concept. of oxidation reduction, in which oxidation is addition of oxygen, removal of hydrogen, and reduction is loss of oxygen and addition of hydrogen. Let's learn some advanced level concept. Electron transfer. We will express oxidation and reduction by loss and gain of electron. So, if any species losses electrons, then this is known as reduction. If any species, if any species losses electrons, it is known as oxidation. If any species gains electrons, then it is known as reduction. And the species which accepts electron, that is oxidizing agent, and the species which donates electron, that is reducing agent. Again, I am repeating, loss of electron is known as oxidation, gain of electron is known as reduction, acceptor of electron is the oxidizing agent, and a reducing agent is the donor of electron. Let's understand by example. The first example is the reaction sodium plus chlorine, 2Na plus Cl2 gives rise to 2NaCl. In this reaction, sodium, the element sodium loses 2 electron to form Na plus, and the element chlorine, Cl2, gains 2 electron to form Cl minus, 2Cl minus. So sodium losses 2 electrons to form 2Na plus. So loss of electron is oxidation. So here oxidation of sodium takes place. Then the chlorine gains 2 electron to form 2Cl minus. So here reduction of chlorine, gain of electron is known as reduction of chlorine takes place. Okay, let's take another example. 2Na plus O2 which raised to Na2O. Here sodium loses 2 electrons to form Na plus whole 2, and oxygen gains 2 electrons from O2 minus. So loss of electron, so oxidation of sodium occurs. Here oxygen gains electron, gain of electron, so reduction of oxygen occurs. Let's take another example. 2Na plus sulfur is raised to Na2S. Here sodium losses 2 electron, Na plus whole 2, so oxidation of sodium occurs, and sulfur gains 2 electron to form S2 minus, so reduction of sulfur occurs. Okay, let's understood some more examples. Zn plus CuSO4 gives rise to ZnSO4 plus Cu, the displacement, single displacement. So in copper sulfate, the copper is Cu2 plus, copper ion is Cu2 plus, and in zinc sulfate, the zinc ion is Zn2. So if we write the ionic form of the equation, then that will be Zn plus Cu2 plus gives rise to Zn2 plus Cu. Here zinc releases 2 electrons, that means zinc losses 2 electrons to form Zn2 plus. So loss of electron is oxidation, so zinc is oxidized to Zn2 plus. And copper Cu2 plus, copper is in Cu2 plus form, copper gains 2 electrons to form copper. So Cu2 plus to Cu, that is gain of 2 electron, gain of electron is known as reduction. So reduction of Cu2 plus takes place, and oxidation of zinc takes place. This is a very simple reaction. In the laboratory, if we take a beaker and we take copper sulfate, then add water, copper sulfate solution, which is blue in color, then we place a big rod inside of the solution. Then after some time we will observe that the intensity of blue color is reduced, the color changed from deep blue to light blue. And finally, the brown layer of copper is deposited on the zinc rod. This is a very simple example of redox reaction. Then we take another example, CO cobalt, cobalt plus Na2 plus nickel gives rise to CO2 plus cobalt 2 plus nickel. Here cobalt losses 2 electrons to become CO2 plus, which is an example of oxidation reaction, and nickel 2 plus Na2 plus gains 2 electrons from nickel, which is an example of redox reaction. We can take another example, that is iron plus copper sulfate. Iron Fe plus CuSO4 gives rise to iron sulfate plus Cu. Here Fe is in elemental state plus CuSO4, in which copper is in Cu2 plus state. So Fe plus Cu2 plus gives rise to Fe2 plus Cu. Here Fe losses 2 electrons to form Fe2 plus. This is an example of oxidation reaction. And Cu gains 2 electrons. Cu2 plus gains 2 electrons to form Cu. This is an example of redox reaction. And another concept is of oxidizing agent and reducing agent. I have said earlier, oxidizing agent is an acceptor of electron and reducing agent is a donor of electrons. Okay. So in this example, zinc zinc donates zinc donates to electron. Zinc donates. So in the reaction, Zn plus CuSO4 gives rise to ZnSO4 plus Cu. In the ionic form, that is Zn plus Cu2 plus gives rise to Zn2 plus Cu. In this reaction, which is the oxidizing agent, which is the reducing agent? As I said earlier, oxidizing agent is the acceptor of electron and reducing agent is the donor of electron. In this reaction, here zinc losses 2 electron, okay, and Cu2 plus, that is CuSO4, Cu2 plus accepts 2 electrons. So acceptor of electron, CuSO4, Cu2 plus is the acceptor of electron. So here it is the which agent? C, acceptor of electron, oxidizing agent. So CuSO4 or Cu2 plus is the oxidizing agent and zinc is the reducing agent. Okay. So in this reaction, as zinc losses 2 electrons, so zinc is the reducing agent and CuSO4, as it accepts electron, it will act as oxidizing agent. Let's take another example. In the reaction, Fe plus CuSO4 gives rise to FeSO4 plus Cu. If we write the ionic form, Fe plus Cu2 plus gives rise to Fe2 plus Cu. Here iron losses 2 electrons to form Fe2 plus. So iron is the donor of electron. So iron is the reducing agent. And here Cu2 plus or CuSO4 gains electrons, acceptor of electrons. So CuSO4 is the oxidizing agent. Okay. So oxidizing agent is the acceptor of electron and reducing agent is the donor of electrons. So now we can easily identify in these reactions which is the oxidizing agent and reducing agent. Understood? In the next class, we will learn about the daily life applications, that is corrosion. Okay, bye.